Hey everyone, welcome to episode 1 of the ClipShow course series. My name's Johnny, and I've been a software engineer for over 13 years. In this course, I'll take you on the complete journey from idea to income, building both a real production application and the business strategy to make it actually profitable. My goal is to teach you real-world software engineering. Not just the basics, but what it actually takes to build production-grade applications. Whether you're looking to start your own business or want to impress potential employers with what you can build and scale, this course shows you the complete process. This isn't another tutorial app, social media clone, or to-do list app that goes nowhere. By the end of this course, you'll have the complete skill set to take any idea and transform it into a production-ready application with real business potential and real revenue opportunities. So what exactly is ClipShow? ClipShow is looking to disrupt the live streaming space by transforming social media content into revenue opportunities. Viewers pay real money to trigger clip sequences they put together in our app, which will also have a Twitch extension, and play it live on stream. We're building this with today's most advanced tech stack, Rails 8.0.2, with their new solid queue, solid cache feature ships right out of the box. Of course, we'll be using this in my favorite front-end library, React.js. One of the things Rails doesn't do well with out of the box is handling persistent web connections, like a WebSocket connection. We'll be using WebSocket connections to power the real-time events needed for ClipShow's core functionality. So we'll need a lot of WebSocket connections, and we'll need them to scale. This isn't something Rails does well with by itself, but I'm hoping that with any cable, we'll be able to scale to as many WebSocket connections that we need and still use all the awesome features that come with Rails. Finally, we'll be using Tailwind CSS to handle all of our styling needs. Our development environment will use Docker, which is commonly used in the workplace to make sure that the development experience is consistent across the team of developers. Now let me show you what we're actually going to be building by walking you through our mockups that we had Claude make for us. So I had Claude make us these mockups that we can go off of, because one of the most difficult aspects that I found to this whole experience is knowing what it is exactly that we're building, what exactly it needs to do. And once we get that figured out, it allows us to focus on more of the technical aspect of just putting this together. So I really am impressed with what Claude is able to generate here. And this is what I came up with for a sign-in page, which I thought was fine. I told it to use Tailwind CSS, which is what we're going to be using in this project. And this is loosely what we're going to use. At first, we're only going to have Twitch sign-in. We won't need to roll our own authentication. We'll use a combination of Devise and OmniAuth to take care of our sign-in process. And if you don't know what either of those are, don't worry, we'll go over both of those in great detail. Once a streamer signs in, this is the experience similar to what it will actually be in the real app. We'll give them like a nice fancy dashboard here, an activity log maybe, and the real thing that is going to be needed is the live control. So from the streamer's perspective, they'll be able to put this on like a stream deck, or I just use an iPad in front of me, and they can trigger their own clips that they've saved from social media, or their own sequences. We're going to call them shows. Just put them together and make that, and be able to trigger them from the streamer's perspective as well, and be able to control what the streamer's viewers will be able to do by pausing and stuff like that. So having it just real simple and basic like that will totally encompass the features that we need from the streamer's perspective of things. Now, the Twitch extension is also very important, probably more important than the streamer dashboard, because this is where the viewer will put together their shows that they want to show on stream, built off of approved clips from the streamer. So this is what the extension is going to look like in Twitch, and this will be its own app that we actually have to build the entire source code for and submit to Twitch. It's a really complicated process, but we'll get through it. Another fun thing that we're going to be implementing is something I'm going to call demand pricing. So in another add-on that I have that we're working on, it uses a similar concept of purchasing tokens that you can use for the redemptions of whatever the service is. What I've found, just the human nature of people, is to just spam these redemptions over and over again. So it would make sense to be able to meter the usage so that they don't get too annoying. And it also gives the streamer an opportunity for an increased revenue stream. Kind of makes things interesting. I think it's fairly innovative, and I'm excited to see how it'll work out. This is what that experience will look like, both from the viewer perspective on the right and the streamer perspective on the left here. If you guys need the ability to create interactive mockups, I am extremely blown away with how well Claude did for all this. I don't know if we'll use every single feature that they generated in these mockups, but it definitely gives me a better idea and definitely helps me with what exactly we're working on so that we're not spending our time spinning our wheels with pivoting on our plans, and we can just build what we know that we need. Let's go over what I aim to achieve in this video. First thing we'll do is show our development environment and go over how I will be writing all of the code and the system that I use and what you may run into if you have a different device than I do. Currently, I'm using Windows 11 with WSL2, which is essentially a virtualized version of Ubuntu, officially supported by Windows. It gives me the best of both worlds with being able to use all of the Windows applications that I need to, while still keeping my development experience in a Unix-based platform. If you don't have Windows, Mac OS is another great alternative, or you can roll your own complete native Linux version if you want. The development environment won't matter too much for this course, as the core fundamentals of building the software, writing the code, learning the syntax of Ruby, all will apply regardless of what system that you're on. We're also going to be leveraging Docker, which will help create a consistent development environment that we all can work in. As you can see, I'm using Cursor Editor here, which is using their AI functionality. I've been trying to adapt more to the AI workflow of things, and I think I'm starting to feel more productive with it. You'll see me use Cursor and AI a lot throughout this course for simple questions and menial tasks that it can do relatively easily. Once we get our Docker environment set up, we'll go ahead and run the command needed to generate our brand new Rails application. Once the code that's going to make up our Rails app is generated, we'll make sure that the application can actually run in our Docker instance. We'll go over everything needed to install Docker in your development environment and get it set up with the Docker file needed to run the dependencies needed for ClipShow. Once we get the container running, I like to make sure that the app can run and doesn't throw any exceptions. Rails has a really nice default hello world page that will aim to get displayed using our Docker instance, and we'll do that at this stage. I'm brand new to this Vite Rails integration, so it'll be interesting to see how that works out, but I have high hopes for it because Vite has made my other Node.js projects a lot smoother. We'll be using Devise for authentication. Devise is a Ruby gem or a pre-packaged library written in Ruby that we can easily inject into our Rails app that handles all the heavy lifting for securely creating users, storing their passwords, and anything else that we may need to do related to user authentication. Once we get our Docker instance up and running and we're able to communicate it with our host machine here, which is the easiest way to be able to load a web app from a Docker instance, we'll get into creating the database and our first model that we'll have, which will be a streamer record. And that's what we'll focus on with being able to authenticate with our application using the Twitch OmniAuth or OAuth 2 API. Devise has a nice Rails generator that will create all of the files that we need to run our first database migration, or creating the necessary fields in our database in order to store the record that we're looking for. The first thing that we'll be installing in our terminal is a Ruby version manager. My preferred Ruby version manager is RVM, which is short for Ruby version manager. If you already have a preference on how you like to have Ruby installed on your system, that's completely fine. If you've never had Ruby installed before or used any of this kind of stuff, I would recommend using RVM so that you can have the same experience that I'm showing in this course here. To install RVM, you'll need to go to rvm.io, and it has these really easy commands that you can just copy and paste into the terminal. And what these are doing is adding the keys that RVM uses to distribute their software to make sure that it's secure. If you get an issue like this with GPG2 not being installed, you should be able to install it with running the recommended command here if you're on Ubuntu. If you're on Mac OS, it'll be a little bit different. Okay, I just installed GPG2. Let me try to run that command again. Excellent. We were able to add Michael Poppy's RVM signing key through GPG. Now we can copy this curl command here, and what this will do is it'll go to this URL, which is actually a bash file, and this contains all of the bash code needed to download RVM, set everything up, and properly install it in your system, and also tying it to your bash profile so that you have access to the RVM binary. So an easy way to install this is to copy and paste their command again. After a few minutes, you should get their donate link here indicating that your RVM install is good to go. And then to confirm that RVM is set up in the local binary files that it needs to be in the path directory for your shell here, you can just run RVM space -- version. As you can see, it gave me an error saying RVM not found. What I did was load my bash profile again, and the bash profile will have at the very bottom of it now an entry that RVM bash file added to it, which loads all of the RVM stuff and sets that up in our path directory so that we can use RVM in our terminal. So once I did that, I ran the command again, and I can confirm that we're running the latest version as of the time of this recording. With RVM installed, we can now install the Rails gem globally so that we can use the Rails generator to create our Rails app. In order to do that, you can run RVM @global do gem install Rails. RVM uses something called gem sets, which allow us to be able to isolate the gems that we have installed if we are working on different projects or if we're testing our project against different versions of Ruby. For the purpose of this video, though, we're just going to be using one gem set, and that's going to be the global gem set. Now that we have RVM installed, we have an easy way to manage gem sets and Ruby installation versions. To install the latest version of Ruby, which at the time of this recording is 3.4.4, we just need to run RVM install 3.4.4. RVM will interpret that as us wanting to go and have it fetch the latest version of Ruby for our platform and install it. Now that we have the latest version of Ruby installed, we can use Ruby gems to install Rails. Rails ships with a generator that can help generate new Rails apps. I think some people refer to it as Railsception. To install Rails, we want to make sure that the latest version is available on the global gem set. Now, we're going to be using an isolated gem set for this project, but because we don't have our project created yet, it doesn't make sense to create a gem set for it. So to install Rails on the global space, we just run RVM @global Rails. And I think we actually have to do global do gem Rails install, or install Rails, excuse me. This will go through and install all of the files needed for the latest version of Rails, which at the time of this recording is 8.0.2. To make sure that your Rails is set up and is working and you can actually call the Rails command, you can simply type in Rails space -- version. And if you get Rails 8.0.2 or whatever version you may be on in the future, then it should be working and you should be ready for the next step. Now that we have Rails installed and we know that it's ready to use, we can use Rails new generator to create a brand new Rails app from scratch. To do that, you run the Rails new command and specify the name of the project that you're trying to create. In our case, it's ClipShow. We have some flags set here to get the creation of the app set up correctly. We're going to be using a Postgres database, so Rails can help us get that configured right out of the gate by specifying this. And the rest of the flags are set to not include a lot of the features that Rails includes out of the box because we're not using them. We are including this skip Docker flag here, but we are going to use Docker in our development environment. By default, Rails will have a production Docker file set up for deployments using their official deployment tool. We're not going to use that, most likely. And if we do, we'll pivot back to it. But for now, we'll keep things simple by not having it included by default. Once the Rails new command is done running, we can go into our new project directory. We're so close to being able to run the app that Rails just created for us, but first we need to get Docker set up in our development environment. When it comes to making Docker files, I always forget the syntax and can oftentimes get overwhelmed with what to put where. So I asked Cursor to create a Docker compose file and the necessary Docker file, we'll need to create our developer environment. It actually did a pretty good job. I had to go through and modify a few different things, but as of right now, this is working, and I am going to update the any changes that I make here and save them to a gist that I'll have linked in the description below for the 3 files that we're using here, which is docker compose entrypoint.dev.shell, dockerfile.dev, and a docker dev binary that we're using as well. If I said 3, I think it's actually 4. And I'll have all these in the description below. So to install Docker, I would just follow a whatever you have access to. If you just have access to Google, just search for latest install for Docker. I just ran through this with Claude, and it worked fine. I didn't have Docker installed on this machine before, so I can quickly go over what worked for me. So in WSL2, to install Docker, Claude had me start with updating apt by running the sudo apt-get update command. This will be for Unix-based platforms, so Ubuntu. In my case, if you're on Mac OS, this will look a little differently. You may be able to install Docker with Homebrew, but again, if you just search for Docker install, or if you have access to ChatGPT or Claude, you can ask them and they'll help you out. After updating apt, it'll have you install a few packages here. These look like standard packages to me that are dependencies for Docker. I didn't have to run this command here. There's already a keyrings directory created for me in etc apt, but if you don't have a directory here, then I guess you have to create one. And then it looks like it's having you go through and get Docker's GPG key and adding it to these keyrings so that you can download the binaries that they release from a trusted source. Very similar to what we did with our VM. This was just a copy and paste for me. This is using Debian to install a .dev file that you're going to get from the Docker official repository for all their versions. So I just literally copy and pasted this in there. If you can't find a guide yourself, feel free to pause the video and copy these commands over. After doing that, it had me update apt again, and then install the Docker and other Docker plugins like Docker Compose, all through apt-get. That went totally fine. And then I did do the recommendation here of adding Docker to the user group so that we don't have to use sudo whenever we run our Docker commands. I added them to system control here in accordance with their recommendation. That should allow for Docker to start every time that we open our WSL2 instance. And then I did have to close my bash profile and open it back up again in order for all the Docker binaries to be set up. And this is actually inaccurate. It's no longer docker-compose. I guess recently they changed it and now it's docker space compose. But with the Docker dev file that they had us, they created for us, it's actually really easy. You don't have to remember all of the Docker flags and everything. There's just kind of like some nice helper methods here in order to run the different Docker stuff, like setting it up, getting it down. You see the container logs here. This looks really cool. So this will be something you'll definitely want to go check out in the gist down below. Once you have those 4 files copied over into their necessary directories, and be mindful, the entrypoint.dev.sh, dockerfile.dev, and docker compose files will all go in the root directory for Klipshow here. It'd be the same for your project. The only file that is going in a different place is in the bin folder here. The docker dev file that Claude created for those helper methods are in here. So make sure that those 3 end up in the root, and then docker dev ends up in /bin in your root directory. Once you have that in, you need to allow that shell script to actually execute. So to do that, you'll run chmod or chmod, whatever it may be, +x to add the executable permission, and then you'll give the path relative to where your terminal is set to in order to change the permissions for the correct file. So in our case, it's going to be bin docker dev. And then you should be able to run bin docker dev up. If this runs correctly, you won't get any errors. You'll just start to see the output like I did here. The very first time that you run this, you'll have a lot longer of an output than I do because I already have the Docker image and all of the dependencies installed, which can take a few minutes depending on how fast your internet is and everything. But once you have the Docker set up for the first time, it'll be running in the background in a daemon here, and we have a nice message showing us that the database is available at its default port, and we can go to localhost 3000 to see that default rail Rails hello world view that we're looking for. So we can open up a browser, and lo and behold, we're able to see that we're running Rails 8.0.2, and this is coming from our server that we are hosting in Docker here. And just to prove that that's where this is coming from and make sure that you're not running anything in the background either, you can go ahead and run the docker dev down command, which will take the containers offline. And if we refresh, it's going to time out. So we should be ready to start actually writing code and building out some of the ClipShow features. It's always good to plan out and think each step of what you're building out beforehand so that you can catch any gotchas before it becomes too problematic to fix them. I created this diagram here to try to help understand how our OAuth flow is going to work and how we're going to be able to completely rely on Twitch's OAuth to authenticate our users and not have to use any authentication ourselves. I know the title of the video and our first screenshot shows that we're going to be using devise. But after further deliberation, I think we can write our own lightweight authentication framework here, and it will further illustrate how some of these protocols and technologies work. So we're going to go ahead and go this route instead. The idea is the client will be served by Rails still. The static assets that make up all of our code, the actual application, will be served by Rails, and Rails will need to start a session that's tied to that user. The session that they're going to create will ultimately start by having the client go directly to Twitch using their OAuth URL. And in this URL, we're going to include a few things about our application that we're going to have to register with Twitch in order to be able to use this OAuth authentication. So the redirect URI is one of the parameters along with the client ID. OAuth follows the pattern of using scopes for the permissions associated to the access token that Twitch will give us. So we'll need to make sure that we have the necessary scopes that the user is agreeing to before we get this on the way. The scopes that we'll include in the redirect URI will allow us to fetch things like the user's email address and anything else that we may need privileged scope for whenever we're using that access token from our server to make requests to Twitch on that user's behalf. With the OAuth flow, there's two different options that can really happen. The user goes directly to the Twitch URL, and Twitch either cannot find the ClipShow application using the client ID that we're going to pass in, or the redirect URI that ClipShow has registered with Twitch as being acceptable to send these access tokens to does not match what the client sent in. In the ideal case here, where the user's using the URL that we have intended for them, they'll go through Twitch, find the ClipShow app using the client ID that will be in the URL, make sure that the redirect URI, which will be another parameter in this URL that you'll see later on, if the redirect URI matches, it will go ahead and continue to send ClipShow an access token that we can use to make an API request to Twitch to get their user information, like their streamer ID, and their display name that we'll use in the app. Since we're relying on Twitch for this authentication, we have to make sure that the token that we're storing for the user is active when we're going to make sure that they're authenticated, because some of our actions in the app might need to make API requests to Twitch. In order to do that, we have to make sure that the token is active and is valid. So when we get an access token back from Twitch, we'll actually get the access token itself, which is the short-lived token we'll use in each request that we make to Twitch on the user's behalf. And it will also give us a refresh token that is much longer lasting and is intended to be used to make a request to refresh the access token once it expires. In order to keep track of all of this, we're going to securely store the refresh token and the access token on the user record, or more specifically the streamer record we're going to store in our database. And we're also going to keep a record of when the expiration is on the access token given from Twitch. We'll use this on each incoming request from the user using the signed JSON web token that we will send them after they've completed the OAuth flow with Twitch. ClipShow will be set up to authenticate the user and make sure that the access token that we have stored for them is not going to expire anytime soon. We'll have a check in ClipShow to make sure that if the refresh token is about to expire, we'll kick off a background job to run the request to use the refresh token in the database, decrypted of course, sending that to Twitch, which will give us a new access token and a new refresh token along with a new expiration. This pattern will complete and is a good balance between making sure that the user's not having to log in every single time that they use the app, while also maintaining security of not having that token live forever. As I mentioned, we're going to have to register our application directly with Twitch so that they'll know how to look up our app when these types of requests happen. To do that, you'll need to go to dev.twitch.tv and either sign up for an account or log in using your regular Twitch account and go through the process of creating an app. Once you've named it, you should get to the console, which is where you can add those redirect URLs that we were talking about previously. In development, we're going to use a service called ngrok, which is a way to expose our development environment to the outside internet without having to forward ports on our router, which increases the layer of security that we'll have with having our device connect directly to the internet. We'll need this because we need to test the flow of our authentication with Twitch. And since we don't have a public-facing server, we'll need to use ngrok to bridge that gap for us. So this domain will ultimately point to our local machine, to our Rails app, and will emulate the in-production OAuth flow. This is why OAuth providers allow you to have multiple URLs associated to your application. The two other fields that are important to notate here are the client ID, which is safe to share with your users, and the client secret. That's something that should stay just between you and Twitch and is a privileged access token specific to your application. So you'll want to make sure that you never store this in your project's repository directly in plain text. Rails ships with a really nice way to store secure credentials like the OAuth token that I just showed you using something called Rails credentials. Rails credentials relies on this master.key file to load if there's not an environment variable set up for Rails master key. In production, you'll need to set this to something secure and unique from your developer environment. This master key is what Rails uses to sign the entire credentials.yml.enc file. If we click on this file, we'll see that it's just an encoded string here because it's exactly that. It's encoded with cryptography. To decode it, you need this master key, which should never be checked into your repository or the same on production and development. In order to easily edit the decrypted YAML file that Rails stores all of our secure credentials in, you can use the Rails command to edit the credentials using this command here. I'm having to set the editor environment variable to Vim so that Rails will open it in my Vim text editor in my terminal here. Once I do that, Rails will go through the process of decrypting the credentials.yml.enc file in the config directory and allow us to see all these keys in plain text. Since this is in Vim, we can go ahead and edit any credentials that we may want to add. And since this is just a YAML file, we're able to categorize our keys like this. So I'm adding the Twitch client ID and client secret for my application that I found from the developer dashboard in Twitch. Again, I cannot stress enough, you need to keep these keys private and make sure that they never are stored anywhere in plain text. Once you save the decrypted credentials.yml.enc file, Rails will automatically re-encrypt it with all the information that you may have just changed. We've discussed this concept of our application accepting web requests from the internet, but we haven't really figured out exactly how we can do that with Rails. This diagram is aiming to show how the inner workings of Rails is and a big part of what makes Rails so useful out of the box. In Rails, there is this mantra of MVC, Model View Controller. What we're showing here is going to be the view and controller portion of that relationship. What we're going to show here is the view and controller side of that relationship. So for example, if a client makes a request to the /tokens endpoint, we need a way to be able to tell our Rails server to deliver that to the correct controller that's suited to handle everything needed related to that request and respond with the information that client is going to expect. Rails uses a file called routes.rb, and this is where we make that declaration for each of these endpoints and where they're going to ultimately end up. You'll see what the declaration of that is in a moment when we go to our routes.rb file. It's worth mentioning that if you were following along here, this is how I originally had my redirect URL set up with Twitch. Since I'm going to follow the path of having OAuth first to know that this type of request needs to go to the OAuth controller, I'm going to use the second part of the URL as the provider, like I mentioned before. So it's worth noting that I'm going to switch these two so that they're backwards in case you were following along and got confused later on. To get to the routes.rb file that's automatically created for you when you start a new Rails app using that generator we did earlier in the video, you'll go into the config directory and it's at routes.rb. By default, Rails will have some stuff in comments and even have a health check endpoint up here to show you how that works. We're going to go ahead and remove all of that to keep it simple. And this is where we'll make the declarations for the different types of requests that we anticipate being able to receive and which controllers, along with which action on those controllers, they'll need to be directed to. Now that we have a working idea of how these routes work from an overhead view, let's actually make the routes that we need to make the OAuth sign-in flow work for Klipshow. To do that, we're going to need a controller that we can use to respond to the request that Twitch is going to make to our server when a user starts the sign-in process. In the routes.rb file here, I've trimmed it out to not have any of the default code that Rails creates with the new project to keep it simple and clean. All we're doing here is writing Ruby code. The rails.application.routes.draw accepts a Ruby block, and in that block, we have access to Ruby methods like get, and we can use it in this declarative syntax to try to help us understand easily, as this routes file grows, what route goes to what controller and what method. So as I mentioned earlier, we're going to follow the OAuth / whatever the OAuth provider is, in this case Twitch, as the URL scheme that we're going to provide for the OAuth stuff. This should allow us to easily scale when we add other platforms like Kick or YouTube. A big part of what Rails does out of the box is creates this framework that allows us to use these functions in order to achieve a lot of functionality our application is going to need. This was always really confusing to me when I started learning this because it was hard to differentiate. Was there a difference between Rails and Ruby? What is Rails? And it was kind of mysterious to me. But if you can look at everything that we write in a .rb file as writing real genuine Ruby, it'll take the mystery out of it so that you can understand more of what Rails is and more of what Rails is not. Since we've declared that the OAuth / Twitch URL needs to be routed to OAuth pound or hash Twitch, this tells Rails, given its built-in configuration, to look for a file in the controllers directory and look for OAuth _ controller. Although we're not putting controller here, Rails is going to look for the file name with controller appended to the end of it. The hashtag followed by Twitch indicates that on this controller, this method is the method that will be called with the request coming in from the internet. In this controller here, it's just a very basic Ruby class called OAuth controller, and it's important that you follow this naming convention because this is what Rails follows to point the requests to the right controllers and where to find them. Just to get some sort of functionality going to this endpoint, I'm going to call p Twitch request in a string followed by params, which is a method that Rails gives us in this context, just to see what the request includes so that we can have a better idea specifically of what we'll need to do to complete our OAuth flow. With just this simple configuration, if we can expose our local web server here to the outside web, we can just test the parameters and really get an idea of what we need to do next. In order to expose anything on our computer to the internet without forwarding any ports on our router, which is typically inadvisable, we need to use something like ngrok. That's what I'll be using here to get a HTTPS public domain that will proxy all the way to my local machine here and allow Twitch to send a request to that endpoint for testing purposes. Ngrok is a free tool that you can use to get your local machine exposed to the outside web. I have a paid plan, so I'm able to use custom subdomains, and I have a custom subdomain configuration set up in my ngrok.yaml file. In order to learn anything about that, their documentation is really easy to follow, and it's a really intuitive thing to use, so you shouldn't have any problems getting it set up. As you can see here, I'm forwarding any request that goes to https://oddjob.ngrok.io to my local interface on port 3000. With our Docker image running in the background, this will get routed to our Rails application, and our puts command, which should just output whatever it is that we put in that string, should show in that console. To make sure that Docker's running, I would just go ahead and use the docker dev shell file and use the down command to make sure that everything is down, and then run the up command to make sure everything starts correctly. Our application is now exposed to localhost on port 3000, so we should be able to make a request as if we were a user signing into our app through the Twitch OAuth flow and see that output in our console. In order to see the output of our Docker instance, which is running as a daemon right now in the background, we can use our docker dev file to show the logs of the Docker containers. I'll go ahead and hold down the enter button so that we can get to the bottom where there's a little bit more space. I'm not sure what these are from. This must be something from a default Rails page that has to do with that health check that we removed. This will actually be the URL that we will point users to when they go to sign into Twitch through our app. The request is made to id.twitch.tv, and we pass along the client ID and the URI encoded version of our redirect URI. Now, URL encoding takes takes the colon / characters that would normally be here and turns them into these %, number, letter symbols here. And that's just so that when Twitch receives this in the string, it can decode it properly since they're not normal symbols. The response type that we're looking for is a code that we'll be able to exchange for an access token. And finally, we'll use the scope section to indicate that we would like channel manage redemptions scope on the Twitch user's account. So if we enter this into our browser, we can expect some sort of exception to be raised because we're not telling the request how to respond in the controller. We're simply outputting the params that we showed you, and that's it. So I'm not quite sure what's going to happen here, but let's go ahead and see what Twitch will send the server, which is really what we're trying to find out. So we can see that this is the URL that Twitch redirected us to, and it has a code in the params here. But we're getting this exception from our server indicating that our ngrok domain is blocked. What we need to do is in the config.hosts array that we can access in the application.rb file or development.rb file, we need to go ahead and whitelist this host here so that Rails will accept the request. Since this is a host that we'll only use in our development environment, I'm going to add this to our development.rb file, which will only be loaded if we have the development mode set when we're running our server, which it is by default now. Whenever changing something in development.rb or application.rb, I like to restart the web server. So just to be safe, I'll take the containers down and put them back up so that we know they're running on the correct configuration. To do that, we'll just run our docker dev down command followed by docker dev up. Now, if we copy and paste that URL into the browser and visit it again, we'll see that we're still getting an exception, but it looks like Rails may have accepted the request because we're getting a different error now. And like I said before, we weren't telling the request how to respond, so this was expected. To see the output of our puts command from the OAuth controller, we'll go ahead and look at the Docker logs here to try to find where that parameter outputted. So as we can see here, Twitch request, this is where we have this in our controller action. And we can see that in the parameter, it's a JSON request, so it's going to be escape. That's why there's these backslashes escaping the quotes there. We get this unique code, which we've already seen, and they return to us the same scope that we passed in to the initial request. So at this point, we know that this is a code that we have to exchange with Twitch in order to get an access token. This is where OAuth can get a little bit confusing. Some people refer to this as the OAuth dance, and it's because the server has to request with the provider, and it's because the server has to make requests with the provider and vice versa. But this is exciting. We know that this is now working in accordance with how Twitch documents this endpoint. So at this point, I'll look in to see what endpoint we need to send this code to in order for Twitch to give us back our access token, refresh token, and the expiration for the refresh token so that we can store those locally on a streamer record. Since we know we're going to have to make a request to Twitch, we need an HTTP library that we can use for Ruby in order to make that request. The preferred gem that I like to use is the http.rb gem. I think it's the fastest HTTP Ruby wrapper, so I usually just go with that and don't have an issue with it. This will give us a great opportunity to take a look at another important part of our project, which is the gem file. All these gems here are what Rails has created by default when we created our project. I've cleaned up a lot of the comments and some of the gems that we won't be using to make it as simple as possible. The 3 sections to our gem file that we need to be mindful of. The 2 in these group blocks here, and the ones outside. In these group blocks, these are gems that will only run in their respective environments. So for this group here, we're sending a symbol called development, indicating that we're only going to use these gems in development mode. This group here specifies development and test, indicating these gems will be loaded when we're in our development environment and our test environment. These are both environments that Rails is able to determine by whatever value is held in the Rails_env environment variable when the server runs. Since HTTP requests on this endpoint can be made in development, test, and production, we're going to leave them outside of the group here so that we always have this gem included in our code. Once we have our new gem HTTP line added to our gem file, we need to bundle this gem to our current gem set. If you remember, we're using RVM and we're not using any specific gem set. So how this is able to work is RVM is able to interpret the bundle command as needing to run the bundler gem and bundle bundle all of our gems together. So to add our new gem, we'll run the bundle command. And now that that's finished, we'll have access to the HTTP library wherever we need it. To take this code that Twitch sends us in the URL and exchange it for a token, we need to make a HTTP post request to the id.twitch.tv/oauth2/token endpoint. Twitch will expect this in the form format and will need to include the client ID, client secret, the code from the parameters of the URL being sent to this endpoint here, the grant type, which is going to be authorization code, and the redirect URI. The redirect URI, client secret, and client ID, all of these are stored in the credentials file. And in order to edit those, you can go back in the video to see how to add those for yourself. For now, we're just going to parse the response as JSON and render it in the view as JSON again. This will just show the JSON response in our browser, and we'll be able to see if it's working or not. Using the same URL we tried before, if we go now, we're expecting a JSON response that will have the access token that we'll be able to store along with a existing or newly created streamer record. As you can see, we got the access token back as we expected. We have our expires in field, which we'll be able to convert into a timestamp, the refresh token, and the token type and scope, which we won't need. Okay, so far we're getting an access token from the Twitch side of things, and we're then able to use that access token to make API requests directly to Twitch on that user's behalf. I say that because all of the endpoints will be scoped to that access token. For example, if we need to get the user's information, we're going to use the access token from this sign-in process to make sure that the information that we're getting from this endpoint is for this user that ultimately is the source of this access token. We're going to follow the same process as before just to keep things simple and make sure that we're on the right process. So we added a private function, and the private keyword, if you're not familiar in Ruby, means that these methods, anything underneath the private declaration here, cannot be called as instance methods anywhere outside of this class, the OAuth controller. And it's a common pattern to use when you're using methods within the controller itself and don't need to expose them to the public. This function just makes a GET request to the user's endpoint on the Twitch API. And for the headers, we're passing in the access token, which it's getting from a parameter. And as you can see, the usage of this method right here kind of tracks you back to how all this is working. The access token is passed into the function. The source of that parameter here comes from our token data, which we got from this request. And again, this is why the OAuth side of things can be a little confusing, and we're trying to do it incrementally so we really understand how this works. So at this point, I would reasonably expect to see our console output here in the terminal. We can also just have the JSON rendered to the browser so that we can get the same kind of feel without having to hunt through all those logs. To test the next step of our functionality, we're going to go to the same OAuth URL that we were before, and we should, if everything goes correctly, see the user's info that we're fetching through the Twitch API with our newly obtained access token. And this looks like a great success. So we get a data array back, and the only entry in it is the user that belongs to the access token, which in this case is myself. So this is working. And now what we're able to do is we can create our own streamer record in our database, and we can store this as the unique identifier for their Twitch account, and we can store their display name to show within the app, and even their profile image we can use here from Twitch to be able to include that as well to give it a more personalized feel. We're finally to the point in all this where we can store our own streamer record that we can use later on and associate it to our own items and our own models internally within ClipShow. But right now there's no model that we've set up, and the database hasn't been configured to store the columns that we need for the model we're looking for here. This is going to allow us to use the Rails generator command to generate a model file and a database migration to update the database schema for all the columns that we need to add and have attached to a streamer record. To generate a Rails model, in our terminal, we'll type Rails G for generate, model, specify the name of our class. In this case, it's going to be user, And then the rest of the fields are going to be the columns that we want to have stored in the database for this record. We're going to have a column called type. This will be a string. OAuth provider ID, OAuth access token, and OAuth refresh token will also be strings. And the OAuth refresh expiration will be an integer. And I just remembered, we'll want a column for display name as well that we'll get from the Twitch response and store that on there to display in their dashboard. This will also be a string. Once we run that command, we can see that Rails has done two things for us. Created a file in db/migrate, and these numbers here are actually the current timestamp that we ran the command. And that's to make sure that each migration is unique, and this is a convention Rails provides to make sure that at any point, as long as we have all of our migration files, we can get the database in the most current state by running a Rails migration. It also created a app models user.rb file. We'll go ahead and look in the migration file first to see exactly what happened. Again, everything is just in Ruby, so as magical as that may seem, all it's doing is generating a file for us that will be run as Ruby. The migration takes one method called change, and we're calling the create table method, which takes a symbol, in this case what the plural name of our database will be for this model, and that accepts a block where we're able to specify all the different columns that we want Rails to set this database table up for. T.timestamps is a helper method that will create the created at and updated at fields in our database. In the user.rb file, all it's declaring is a class inheriting from the application record class, which is another file created from Rails. And this is where all of our associations, validations, any methods specific to users that we'll need will go here. Now, my plan with the user record is to set up something called single table inheritance. What that allows is for a class like user to have other models associated to it without having their own database entries. In other words, we'll be able to leverage that type column that we specified to differentiate between a user that's a streamer and a user that's a viewer. There are certain scenarios in the application where these two different types of users will be treated differently, and we'll need to know what type of record we're dealing with. We should have a pretty decent understanding of what the Rails generate command just did, and in order to have those changes actually be made in the database, we have to run another Rails command called Rails DB migrate. What this will do is run the very last migration that hasn't been checked into our db.schema file, which I can show you in just a moment. Any file that hasn't gotten run will be run, and any database changes that are made from that we'll see once the migration is finished. With our migration ready to run, we can refer to our docker dev shell file to run the migration on the container that is actually serving as the Postgres database for us. To do that, we'll type in bin docker dev db migrate. And we know that that's the command because in our docker dev shell file, that is one of the switch statements here. And we can see what command is actually going to be run here. It's docker compose exec web bin rails db migrate. This is the command that we would run if we did not use Docker in our developer experience and we're just using Ruby locally instead. It's the same thing. It's the same thing, bro. Once our migration is complete, we can tell that it completed because we didn't get any errors, and it shows that our new users table was created. To make sure that our new user is available and not raising any exceptions in the Rails environment, we can fire up a Rails console remotely to our Docker instance that's running our Ruby app by using the docker dev helper again. We'll just run bin docker dev console, and that'll connect us to a console in the locally running container. We can initialize a new user to see what attributes are made available to us. Even though there's nothing in the user class yet for all of these attributes that are available on the Ruby class, we're still able to access them. This is something that Rails does under the hood for us, and the reason that we're inheriting this class from application record. Now that we've confirmed that our user record is set up in the database and ready to go, we need to start making sure that we're storing data very securely. Since we're going to be storing sensitive tokens, it's best practice to make sure that the actual values that are stored in our database are not in plain text and are encrypted. This can normally be a bit of a hassle with having to write your own encrypt and decrypt functions, but thankfully, Rails has encrypted columns available for us to use right out of the box. We can declare them in our user by calling the encrypts method and passing as symbols the columns that we want to be stored as encrypted fields and decrypted in plain text whenever we're using them. So we get the best of both worlds. The reason this is best practice is if ever your database is compromised, the attackers only have the values that are in the database. And since you're storing encrypted data, they're not able to decrypt it without your master key, which Rails is going to generate for us here in just a moment. To generate the keys that Rails is going to use to sign all of these encrypted fields, we have a Rails helper method from the terminal we can use. To run this, we'll type db Rails db encryption init. What this will do is spit out 3 different keys that we'll use to sign all of our encrypted fields in Rails. This is generated for us in the most secure way that we have access to. So this is a safe way for us to generate secure keys for all of our encrypted fields to be signed with. Now what we need to do is add these to our credentials file, and I referenced earlier in the video how to do that. I'm not going to show it on screen because I don't want to have to reset all of my access tokens in there, but you should be able to figure it out. We'll just run editor vim for me. Vim is the text editor I'll be using for this. And then you'll run Rails credentials edit. That'll pop up your YAML file with all of your credentials in there, and you'll add this entire block to the very end of that. This will allow Rails to be able to look up the active record encryption column and the primary key, deterministic key, and key derivation salt. To test that our fields are actually being stored correctly in the database, we can run a console on the Docker instances running locally to be able to create a user record manually. To get into a Rails console running in our Docker container, we'll use the docker dev shell file and pass in the console flag. Now we're in a Rails console where we have direct access to the database. I'll emulate creating a new user with an access token that we do not want stored in plain text in the database. If you look what was actually inserted via SQL, this is the field that got put into that column. As you can see, that's far from plain text, and it's a few things that Rails needs to decrypt that value on the fly. So now if we go into user.oauth access token, we're able to see it in plain text, but in the database, it's stored encrypted. While writing the next piece of code here, I just realized that I didn't include a profile image URL column on our user record, which I did mention we are going to want to use for displaying in the streamer dashboard. Now, although we've already run our migration, since we're in development and none of this code has made it into production or onto any other developer's machines yet, we can kind of cheat and go back and just fix the original migration that was created, drop our database, which destroys the entire database, and then create it from scratch and run the migrations again. It'll be like we never forgot to add that column. The change that we need to make is in the only migration that we have so far for creating users. We're just going to add another string column called profile image URL here. It's worth touching on what the schema.rb is, which is very important. This is what the end result of our migrations will create, and this is what Ruby goes off of to keep all Ruby models in sync with the database based on their respective columns. This is a file you should never edit manually because that process needs to be handled by the migrations. The reason we're able to fix our original migration file and drop the database and run it again is, like I said, the error never made it anywhere beyond our computer. So since we're the only ones that know about the issue, we can fix it this way, and when we share this code or deploy it to production, there will be no issues. Now that we've updated our migration, we can delete the schema.rb file that Rails goes off of to get the current version of what the database should look like in Ruby, and we can run the docker dev db reset command, which should regenerate a new schema, adding the new column we forgot to add initially in our migration. I'm getting an error here because the Klipshow web server has a connection to the database right now. So I'm going to go ahead and take the Docker containers down and then run the command again. As you can see, we got an output similar to before. And now if we go and check in our db folder, there's a new schema file and our profile image URL string column is there. Now everything is matching the migration and the schemas, and we can move on to the next step. In our OAuth controller, we can now create a user given the access token that we just received from Twitch's OAuth response. All of this information is coming from the response from the user info method that we're getting here. And if this works correctly, we should see our user rendered in JSON displayed in our browser. To test that, we'll go to the same OAuth URL with Twitch. And as you can see, we're getting a JSON response here that includes all the fields that we would expect. From this code, we know we're able to create a streamer from the user's request to the OAuth flow with Twitch. And this is great for now, but our functionality is going to get a little bit more advanced because we need to handle the ability to just sign a user in if they've already had a database entry created. This is a great time to transition into writing tests for the code that we write. The backend testing framework that we're going to use for this course will be RSpec. Rails ships with Minitest by default, which is a great framework, but I do have a preference for RSpec. First thing we'll need to do to get RSpec working is add the RSpec-Rails gem to our gem file. According to the RSpec documentation, they are placing it in the development and test groups, even though this should only be used in the test environment. So I'm just going to go ahead and place it here. To add our new gem, we'll run the bundle command from terminal, and this will add RSpec and all of its dependencies. RSpec includes a generator that we can use when we're very first getting it started. To run it, simply type Rails generate RSpec install. This will create a few files for us that we'll use in all of our tests throughout our test suite. Now that RSpec is set up and ready to go, we'll create our first spec in the new directory that RSpec just created for us here. We'll create a subdirectory called controllers, since that's what we're testing, and we're going to follow this naming convention here of OAuth _controller _spec. The rest of our controllers will follow the same naming convention as well. We want to test the functionality that we've proven to work so far so that it stays working the way that we expect it to. We won't go too in depth with RSpec and how it's used here, but it's a Ruby DSL, or domain-specific language, that allows us to write our tests in a really declarative way. One of the nice things that RSpec allows for out of the box is being able to mock HTTP requests. What this means is instead of having our web app actually make requests to Twitch, we'll mock those requests in our code and mimic a network request coming through, but it happens locally. So we don't depend on the outside internet to run our tests, and we're not hitting the Twitch server every time we run our test suite. We can also make sure that the requests to Twitch are including the correct information and return the necessary information that we need for our user's endpoint to get hit as well. We follow the same pattern there. If you'd like to see a video going over RSpec in more detail, leave a comment down below. Yeah, I'm a fucking comment down below right now. What we're doing in this test is mimicking the payload that we're going to get from Twitch when we receive an OAuth request and the request that gets returned when we look up the user's information using an access token that we just received. Here we're mocking those HTTP requests, making sure that when we make the request to get a token in exchange for the code that gets sent to our endpoint, and then once we get our token back, we'll mock the request getting the user information and make sure all the information in the headers is correct. You can see that these are wrapped in a before do block here. And what that means is that before each of the tests below in this describe block, it will run these commands here. It'll run this code here. Right now, we just have one test because we're trying to prove the very basic functionality we've already written. This is how we emulate a GET request to the endpoint that Twitch is going to be using for the OAuth flow. We're passing in an OAuth code that we set up above, and we're declaring that after this request is done, we should have a new user by declaring that the user model count increases by 1. After the request is made, we're going to go ahead and fetch that user, make sure that the fields are filled out as we expected from our sample response here. I had Claude generate these tests for me initially, and I thought I would keep this block in here, but I think since we're using the Rails encrypted API, we don't need to test that functionality. All that functionality is tested very thoroughly in the Rails library. To run our tests in our container, which we'll need to do because that's what has access to our isolated Postgres instance, we're going to need to modify our test helper method here and specify the environment variables for the database URL and the Rails env before we run bundle exec RSpec. Remember, this will be running in the web container when we run this command. We'll run this helper method with the bin docker dev test command in terminal, and if everything went correctly, we should see that we have 1 example and 0 failures. This isn't the first time that I've run this test, and if this is your first time, you may need to run this command here, which sets up the ClipShow test database for our test environment on our containers. Once you do that, the container will be able to connect to the ClipShow test database where all of our isolated tests will run. So far, we've handled the functionality of creating a user whenever a request comes in here for the first time. This isn't ideal as the only functionality, as each subsequent time a user logs in, we want to just return the record that we already have stored for them and not continue to create records. The total functionality that our endpoint needs to solve for is creating users for the very first time they sign in and properly handling for users that are returning and signing in after they've already had a record created for them in our database. To do that, we're going to treat this request as if it can handle either by initializing our user record here by using Rails find or initialize by method, and we're going to use the OAuth provider ID as the unique key that we're going to use to identify this user with this OAuth provider. And then regardless of if there's a user in the database already or not that matches this criteria, will have access to a newly created user record. So regardless of if there's a user in the database or not, our find or initialize by method will always return an instance of our user class. This allows us to set the access token and other properties on this the same way, whether it's a new user or an existing user that we're updating the information for. This is a nice approach because if, for example, the user changes their display name or profile image in Twitch, the next time that they go to sign in, we'll get that information stored on our database and it will be the most current version. Back in our OAuth controller spec file here, we're going to go ahead and add another context. The context that we created here was for when a user is being created for the very first time. The context for these tests are going to be when a user already exists. And if you're not familiar with RSpec, it just makes it so that these organize the tests a little bit easier. It doesn't really do anything beyond that. Here we're going to create an existing user in the database, and the let with a bang operator at the end means that this will get created before the test runs so that the record returned here is available to be used in the test. We want to make sure that if there's already a user in the database with that OAuth provider ID, that we're not creating a new one. So the first test here makes sure that even when a user signs in that already has a record with this OAuth provider ID in it, we're not going to create a new record. This can be handled with validations at the model level, but for sake of ease now, we'll keep it like this. This test here makes sure that if the current user that's in the database has differing information from what Twitch gives us when we go use the get user info function, and if we wrote all these correctly, they should pass, and we'll run these by running our bin docker dev test command. As you can see, we have 3 examples here and 0 failures, so we should be in good shape. If we consult back with the diagram we went over explaining how our whole flow of authentication is going to work, we're at this point here where we're able to store everything in the database, but we need to return a signed token that the user will be able to use in any request that they make to Klipshow and have it work in authenticated areas that require privileged access. We're already storing or updating all of the user's information here. The only thing that we're adding is a reference to the new token service that we're using, which we'll show you in just a moment. This will take the user ID that we have in our local database and encrypt it into a securely signed token that we'll give to the client to use in any subsequent request that they need to make and authenticate with on Klipshow. We're rendering this back to the client in JSON, including the token that's signed here, the user's display name, which we're getting from Twitch, as well as the profile image URL. We'll use these 2 pieces of information to display the user's info in the streamer dashboard. Our token service is very simple and leverages active support message encryptor, which is shipped with Rails right out of the box and is a secure way of signing tokens for instances exactly like this. It uses the same master key that our credentials are signed with. We'll use these class methods here to validate a token passed in from the user, which we expect to include a user ID, as well as signing a token and returning it back to the user. In our OAuth controller spec, we're mocking the calls that are being made in the controller itself to token service because we don't need to test the functionality that's responsible for token service. We'll write specs specifically for the token service that isolates that functionality. We just need to make sure that the token service methods are called as expected and are called with the parameters expected as well in our controller action. So here we're just mocking that and returning our stubbed generated token variable, which we have up here at the top. And then we're making sure that our response body now has the display name, profile image URL, and that token that should have been returned from our mocked call to token service. We're also making sure that token service was in fact called with the user ID, which is what we expect. In our user already exists context, we're also checking that the token service is called as expected, and we're having to use the active support travel to method here to lock in our timestamp to make sure that the expiration is what we anticipate. The reason we have to do this is that we're using references to time.now, which can be different in between when the test is run and the test completes. So using travel to a specific time will lock in the time for this entire test and then unlock the time once the test is done. We've also written some specs for our token service here, and this just verifies the functionality of generating a token, validating a token, and making sure that invalid tokens return a nil response. We can go ahead and run our entire test suite and see if everything is working as expected. As you can see, all the tests are passing, which gives us some confidence to move on to the next step. Although we don't have anything yet that might look like an app to our potential users, we've actually accomplished figuring out and getting a core piece of functionality working for our app that we'll use from now on. This is a good jumping off point to slightly switch gears contributors and to start working on our front end. Since we're at a good checkpoint, I wanted to comment on the cadence that I like to get into with committing files into version control, making sure that that's always getting done on a regular basis. We're going to be using Git and a private GitHub repository to store all of the code for ClipShow as we develop it. The habit that I get into is running git status at any time that I'm working on something, and this will show me in red all of the files or folders that are not currently checked in to our current branch. I've already started a ClipShow private repository that I'll be pushing this code to, and I've added all of the files and folders that we've created thus far to staging in our Git environment here. Here's the commit message that I'm going to add for our very first commit here. A lot of the times you'll see people just put initial commit. Since we didn't just commit our code after generating our Rails app, we did a little bit more than that. I want to add a little bit more description to our commit message so that if we ever need to go back and read it, we can know what code was changed in this commit. And it's also a really good habit to get into if you're going to be working on a team of developers and they need to know what code is represented by this commit. I just pushed the code to the repository, and Git gave me an error at first saying that the branch that is currently in the repository is different than the branch I'm trying to push. Since the branch only had a README file in it from when I very first created the repository, I just force Git to push the files there. And if I refresh the screen here, we'll see that all of our code next to our commit message is now in our repository. This will set us up nicely to be able to continue to add to our version control as we develop the app, which is a really good habit to get into whether you're a solo developer or working on a team with other engineers. Before we get started on writing any code that our users are going to see in the browser, we have to take a step back and make sure we have our system design in place to support writing code that is going to allow us to use JavaScript along with any other language we need for the front end, compiling it and serving it in our developer environment as well as in production. This diagram aims to explain what my thoughts are on how we're going to put all this together and what tools we're going to use to accomplish it. So as I envision it, we're going to have in our application file a lot of JavaScript and CSS that we're going to need to keep track of, make sure that we can import from one another, and ultimately get into the browser, which is where this is going to be served. I'm going to try the new Vite Rails gem that I've never tried before because Vite is going to be our intermediary between the Ruby world and JavaScript. From what I've read in the Vite Rails documentation, this aims to provide an easy gateway to manage all of our Rails app code in one repository. As we start to add JavaScript to our application, we're going to set this up to have Vite take care of either compiling the code into a production-ready format, in which case we'll just serve that from the public directory through our Rails app, or if we're in our development environment, we'll use the Vite server to serve those assets over the wire and ultimately get to the pages that our Rails app is going to use. In either case, we're going to rely on Rails to serve the HTML as well as the static assets. Any of the compiling that will need to happen to prepare our assets to be served in the browser will be handled by Vite. The only inherent limitation that I see from this design right away is that we're using our Rails app to serve these assets over the wire. Rails isn't meant to act as a content delivery network, so as we look to put this application in production, it's going to be worthwhile to start looking at different content network providers in order to serve our assets for us in a better way than Rails. We want to keep Rails isolated to handling the business logic of our application and not having to waste system resources on serving assets that something much better like Amazon S3 can do for us. With the first iteration of our system design on how our front-end code structure is going to look from an overhead view, we can go ahead and start to implement this. But first, let me take a bong rip. First thing we'll do is add the Vite Rails gem to our gem file here in Rails. To bundle this together so that it's ready for our app to use, just run the bundle command. This will install Vite Ruby and all of its other dependencies that it needs, which aren't very many. And I took the time to make sure that we're not going to add too many dependencies to our app. Another habit I get into right away, because the more code that we add, the more code that we have to maintain. And this is a nightmare inevitably for every developer. With our gem bundled, we'll be able to use the generator that Vite ships with out of the box. To use that, we'll run bundle exec vite install, which will create the configuration files needed for Vite Rails to run, as long as give us some boilerplate to start with. One of the files created is this vite.json file in the config directory of our Rails app. If we take a look at the JSON file here, it makes up a few configuration details that Vite's going to use. It's going to look for any JavaScript in our app JavaScript folder, which is created by default with Rails, which already aligns with the Rails way of doing things. Inside the JavaScript directory, Vite created an entry points folder for us, which is where we can use top-level files like application.js, and this is that boilerplate that I was referring to. Right now, if we go into a web browser and load our app running at port 3000 with our Docker instances running, we'll see that we're still just seeing the Rails default page. The reason for that is that we haven't declared a root path for us to serve when requests to the root path come in. As we can see from the functionality that we've already gotten working with the Twitch OAuth flow, we can see that Rails expects a method call with these parameters input to it. The root declaration is no different, other than get will use the one-time root method that will declare the root path for our users. I'm going to set this to use the streamers controller and point to the new method on that controller to serve our default response to this application. We haven't created the streamers controller, so we'll go ahead and do that now. To do that, we'll go over to the controllers directory underneath app, and we'll create streamers_controller, following the same convention as the other three controllers that we currently have in the application. We won't need much to go here at first, just to serve a regular static view that we can use to make sure we're heading in the right direction of being able to display that sign-in page that we had Claude generate for us in our mockups. We'll just create a regular Ruby class inheriting from application controller, and we'll declare that new method right here. By default, Rails will look for a HTML file in the streamers/new.html file in our app view directory. So to get there, we'll go app views, and here we need to create a folder for our streamers controller. Rails also ships with this PWA folder, and I don't think we're going to need that, so I'm going to remove it now. I've created a streamer directory and placed a new.html.erb file here. ERB stands for embedded Ruby, and that will allow us to take advantage of Rails template renderer action view and render Ruby code right in our HTML. To make sure this page is loading, I'm just going to put a simple heading here and make sure that it loads in the browser. So I'll add a header called streamer sign-in page. I just tried to load the view in our browser, and I see that we're getting this unexpected exception here. Looking back in the code, I see that I accidentally added the streamers directory underneath the layouts directory. We'll need to move that to be directly under the views directory in order for Rails to know where to find our HTML. Loading the request again, we still get an exception, but we know what this one's for. Earlier in the video, I removed the import maps Ruby gem because we're not going to use it for this project. Import maps is another way of being able to serve assets from Rails while keeping all of the code under one repository. The JavaScript import tags method here in our application layout, which is the default layout that Rails will use to render our views around in this yield block here, we can go ahead and remove that altogether. Since Vite uses npm, we need to modify our Docker file to make sure our npm modules are being installed. In our entry_point.dev.sh file, we're going to need to add a line at the very bottom that installs all of our nodes at this point in the up command of our Docker instance. To make sure our Docker image is properly built, we're going to run the docker compose build command from the terminal. Once that's done, we should be able to use our docker dev shell file, passing in the up flag to bring the containers back up that we just rebuilt. Now, if we go to localhost 3000 in a browser, we should see our streamer sign-in page. And if we look in the console, the dev tools, we'll see that we're getting the Vite Rails console.log, indicating that our application.js file is going through the Vite pipeline correctly and ultimately being served to our client. This should put us in a good place to start actually building out the front-end code. Since we're using Vite to handle all of our JavaScript building, we can leverage the Vite Tailwind plugin in order to integrate Tailwind seamlessly with Vite. We'll install the Vite Tailwind plugin by running npm install space tac D, which indicates we're saving it to our package.json file here underneath the dev dependencies area. Once we have that done, in our vite.config.ts file, we should be able to add import Tailwind CSS from our newly installed npm module and run that in our plugins here that we're using in the Vite config. We'll need to install a few packages to make sure that we're ready to use React.js on our front end now that we know that we're serving a basic HTML response from our Rails app. To get React working with our installation, we'll need 3 npm modules: the core React library, React DOM, and the Vite.js plugin for React. With our node modules installed, we'll need to go to our vite.config.typescript file. Here we'll import the React plugin, register it here by calling it as a function, and making sure that Vite resolves all files ending in .js and .jss JSX to compile into what React will use to render their components. With all of our React node modules now installed, we'll need to add a new entry point for our React.js components. We'll put that under JavaScript entry points along with our application.css, application.js files. We're just going to call it react.jsx. We're going to import React, create root React method from the React DOM client library, and then an app component that Claude created for us while walking us through how to get this set up. This file also takes care of making sure that our React components get rendered after the page is loaded, which is what this is doing here. And this line is what makes this file have to be a .jsx file so that it is compiled correctly and rendered to our browser. We'll then go into our application.html.erb layout file. And just like how we had to add the Vite style sheet tag, we are going to add the Vite JavaScript tag, and we have to declare the path this way. And I think the reasoning for this is because we're using a .jsx file, and this is just how Vite needs to read this in order for it to work. So if this works correctly, our react.jsx file should load and recognize that we have a root element, which we've declared here in our layout. Import our app component, which is just a basic component to test to make sure that this is all working. Find the root element, and if it does find it, mount the component via React. So if this works, we should be able to reload our screen and see this React component in HTML. We'll go to localhost 3000, and as we can see, this is all rendering now, and our app is finally starting to come together on the front end. We've just demonstrated that our build process and being able to render React components inside of our Rails app is working. However, this only gives us the ability to have one main component entry into our application, which would work for a single page application, allowing the React side of things to handle all of the routing. But we're going to use a bit of a unique and hybrid approach, which will allow Rails to maintain all of the routing, and will create a helper method to render our React components inside of a Rails view, which will give us the best of both worlds, being able to write basic HTML with Tailwind CSS supported, and using React where we need a little bit more functionality. The first thing we're going to do is remove the root reference on the body tag in our application.html. This isn't where we want React to be entered into our application, because we're not going the route of creating a single page application where the front end is handling the routes of different views. We're still going to be using the Rails view way of rendering things. We'll modify our react.jsx file underneath the entry points directory here to handle looking for components that are rendered on the page from Rails and essentially hooking them up to React to make sure they function as we expect them to. So we're going to create a custom React component called component renderer, and this is what's going to find the component that we have here in this component registry object that we'll use to bridge the gap between what Rails will be able to call the component in the view and what we can find and have render as a React component. Then we'll add a event listener to the DOM content loaded event, which will fire after the page has been loaded and is now ready to execute JavaScript. Inside of our Rails helper method, we're going to assign it a React component data attribute, and we're going to find all of those by using that data attribute. We'll then loop through each component, finding the correct component based on its data set, parsing any props that we can use. This is another benefit to this hybrid approach in that we're able to have Rails generate any props that we may need that we can store in instance variables or other helper methods in our Rails app. And then the rest of the process is the same as what we did to render the proof of concept of making sure our React stuff is hooked up on the first iteration. We'll just render this new component renderer, which will have our right component that we'll start adding from the component registry, and this should work really well for us. We'll declare our helper method for rendering the markup needed for this React component in the application_helper file in the app helpers directory in Rails. Content tag is a helper method from Rails that we're able to use here to render a div that has the data that we need for our React.js entry point file to find this component, know that it needs to be rendered as a React component, and make sure that all of the props that we can pass into it from our Rails view are being parsed correctly. I just realized it'll be useful to specify a class as well to have the React component wrapped in any container that we may need it in. To see this in use, we're going to the new.html.erb file, which is under our app, views, streamers, new file, and we're going to use this React component helper method that we just declared. We're going to declare that we want to render the sign-in component here, and we're going to pass this in as the class object for that div component to get applied so that we can make sure the React component is styled as we need it to be. And then in our react.jsx file here under entrypoints.react.jsx, import this component, which we have stored in the JavaScript streamers signin.jsx file, and then we'll add it to that component registry. And this is the key that we're referencing from the Rails helper method. And then we're storing the value to that key as the React component that we're exporting from this file here. This is the React component that I literally copy and pasted from that mockup we had Claude create for us earlier. I slightly modified it by having the main wrapping container element rendered at the Rails view level and keeping the styling isolated to the React component here. That's how I remembered that I needed to add a class argument here to allow for the helper method div to be wrapped in the class that we need so that it can be styled however we need it to be. To make sure that Vite is able to see these changes that we're making to our new React components, I made sure to add all of the directories and subdirectories that we may have components in to make sure that this is working correctly. We'll make those changes under the config vite.json file that the Vite Rails gem created for us. Now, if we have everything set up correctly, we should be able to see that sign-in page very similarly to the mockup Claude created for us, but this time in our own application where we can actually start to make it work. Loading the app up, thankfully we can see that this ran, and this should verify that our current approach for creating React components and making sure they get compiled correctly is working. Some lore behind the ClipShow logo here is the original plan was to have it ClipShow with a C, but when I went to go purchase the domain name, .com and .io for ClipShow with a C was taken. Thankfully, ClipShow with a K for both .io and .com was available, so I snatched those up, and I think we'll be able to make something cool out of the K instead of C as well. The first thing that I noticed from our mockup that Claude made for us is it's including multiple ways to sign in and even a way to sign up. Our plan from the beginning has been to just use Twitch OAuth authentication for our streamers for now. We may add other OAuth providers in the future, but for now, this form only needs to have a continue with Twitch button. In our sign-in component here, I removed all of the elements that we're not going to be using, officially changed the C to a K, and removed all the buttons except for the continue with Twitch button that Claude created for us. If we go back to our app now, we'll see a much simplified version of our sign-in page, and this is what the users will see before they go to sign in to their account via Twitch. The next big functionality that we need to figure out is how we're going to have the user emulate what we were doing at the very beginning when we were testing what needed to be done for the OAuth flow with Twitch and ClipShow to return us a secure token that our users can use for authenticated requests being made to ClipShow. This diagram aims to show you what I'm thinking with how we're going to make this work. We have the ClipShow server, which renders the sign-in page. That's where we currently are. We need to make the sign-in page open a new window that goes to that URL we were using to pass the client ID and the redirect URL to the Twitch OAuth sign-in page, which will then make a request to ClipShow, doing all of the functionality that we got working earlier. ClipShow will then need to render into this new window that we've opened a special view that will communicate the information we just received from ClipShow to this page so that we know this window can now be closed. We'll be using the post message protocol with JavaScript to communicate between the sign-in page and this new window here. Once we have the plumbing hooked up for this new window, we'll be able to take the response that we get, which includes the token, display name, and user's profile image URL, set it into our local storage, and once it's in local storage, all of our components will be set to look for it whenever we need to make a request to ClipShow for all of their authenticated resources. Let's start by going back to our OAuth controller and changing it from rendering a JSON response to just setting instance variables that we'll use in the corresponding view for the Twitch method here on the OAuth controller. We'll need to make an OAuth folder under our views directory, and we'll call it twitch.html.erb, which is no coincidence to what is matching here to the method that we're actually using in the route itself. All this is going to do is render some JavaScript that we'll use to send this information back to the window that opened the window that this will be viewed in. Remember, we're opening a new window from our sign-in page, and this will be viewed in the context of that. So JavaScript allows for us to communicate a message from the window that opened this window by using a method called postMessage. We'll pass along the type of event that this is going to be. This is just something that we are going to call for use in our React component. And then we'll send an object with these instance variables embedded directly into it. So what this will do, once Twitch grants Klipshow the OAuth token, Klipshow will redirect the new window to this view here. Our original sign-in page will be set up to be listening for this message. And once it receives it, we'll have that sign-in page redirect to the streamer's dashboard URL. We need to add a view where our dashboard will be rendered, as well as a route that can direct it to that view. We'll add a route to dashboard here, and we'll send it to the dashboard controller on the show action. Underneath controllers, we've added dashboard controller. This controller is just an empty class with the show method defined so that our view can render. Underneath views, we'll need to create a folder called dashboard, which is no coincidence to the dashboard controller convention we're using. We'll create a show.html.erb file, and we're going to use our React component helper method to render a dashboard component. In our react.jsx file, underneath JavaScript entry points in the app directory, we'll need to import the dashboard component, which we'll store in the streamers folder with our sign-in component, and we'll just call it dashboard. We'll register it to our component registry here. Again, this is how Rails is able to reference this component in JavaScript. And then in the streamers folder, we'll create that dashboard.jsx file. We're going to use a service for fetching and checking for the user's JSON web token that is going to be stored in local storage. We're going to import the current streamer object, the current streamer method here, which will return that streamer object from local storage, parse it in the string format that it's in into JSON so that we can access the token, display name, and profile image URL properties on it. For now, just to prove that this works, we'll go ahead and just display the streamer's display name, profile image URL, and if we see these in our view, we'll know that this is coming from the object we're storing in local storage. To trigger the new window to open once a user clicks on the sign in with Twitch button, we'll have it go to a handler in our React component here. And this is how you're able to set up a new window using JavaScript. Here we're just defining the size of it, and this should center it in the middle of our parent browser. And then we're sending in the Twitch URL that the user needs to go through in order to authenticate with Twitch. And we're passing in the Twitch client ID, which we're just storing up here for now, as well as the Twitch redirect URI. We'll need to remember to either integrate a better way of swapping these URLs out or remember to change them before we build our production front end and have it go to our production server. But we'll handle that when we get to it. Calling the window.open function with these arguments will create our new window, and we'll add that event listener for message, which is how we'll receive messages from the view that Klipshow will redirect this request to. If we get an event back and it's our Twitch OAuth success, we have confidence that we just received the token and the user is now officially authenticated, and we'll go ahead and store the streamer using our new store streamer method that we'll show you in just a moment, which sets this information to local storage. And then we'll manually redirect the user to the dashboard URL, which is what will ultimately render our dashboard component here. So if we refresh our page here and click the continue with Twitch button, we'll see our new windows popped up in the middle of our parent browser, and it's asking us to sign in. So I'll go ahead and sign in using my Twitch credentials as I normally would. And once I sign in here, we should see this window shortly after disappear, and for our parent window to go to the dashboard view. As you can see, everything went through correctly, and we're getting our dashboard component rendered here. This is a great time to check all of our recent progress into version control. Even though we only have a proof of concept working for our dashboard, we've still accomplished setting up our front end to be able to build, as well as the directory structure for our React components. I'll go ahead and add a descriptive comment message here and push this up to our repository. That's going to wrap up episode 1 of our Klipshow course series. series. In this episode, we went from nothing to a freshly created Rails 8 application, wired with everything needed to make Vite, Tailwind, and React all work well together, implemented a strategy for scaling our React components while still leveraging Rails, and got our OAuth sign-in system working. Right now, users can sign in with their Twitch account and land on their ClipShow streamer dashboard, just showing their display name and profile image. It's simple, but it serves as the foundation for everything we're going to build. This puts us in a great position for episode 2, where we'll start tackling more of the dashboard features we're going to build out. We'll start with looking at what needs to be done to link a streamer's social media accounts so that they can start using the content management system. This is where we'll build out the system needed for the streamer approving any of the clips that will be used in their stream. If you're enjoying this series, please make sure to hit the subscribe button and the bell to make sure you get notified the second part 2 comes out. And if you're watching this in the future, I'll post part 2 in the comments below as soon as it comes out. If you want to see this development happening live in real time, I stream every single day on twitch.tv/oddjob. If you want to watch me work on this course and ClipShow live with the ability to ask me any questions you may have and influence the build of the application, head over there and give us a follow now so that you can get notified next time we go live. Let me know in the comments what you think of this video so far and any suggestions you may have moving forward. That's going to do it for me. I'm Johnny. Take care. We'll see you in episode 2.